In today's video, we are going to talk about how to do dilations on a coordinate plane. Let's go ahead and get started. So first off, and this is partially done. I already partially did this on Alex, but notice that it says, in the figure below, do a dilation centered at the origin with a scale factor of 1/2. Now originally this little slider is set at 1, and in order to perform a scale factor, in order to perform a dilation, we slide that down here to 1/2. So that's the first step. If it said a scale factor of 3, I'd slide my little slider up to 3. So that's the first step. The second step is just to answer that question, where are my endpoints? So on my original figure, that's the gray one, that was my original. Here are my two endpoints. On the left, I have the ordered pair 4. So remember, all points are x and then y. So the x value is 4, the y value is 2. And my right point, the x value is 8, and the y value is 8 as well. Now the endpoints of my new figure are down here at 2, 1, and right here at 4, 4. Now what I want you to notice is with my scale factor of 1/2, my line got 2 times smaller. But not only did it get 2 times smaller, it also, the endpoints got 2 times smaller, or it got cut in half. So if I, with my calculator, take 4 and times it by 1/2, I'd get a 2. If I took a 2 and times it by 1/2, I'd get a 1. If I took 8 and times by 1/2, I'd get a 4, and the same thing. If I times 8 by 1/2, I'd get a 4. So that's what dilations do. They take all of my points on my line and they shrink them by half. So if I do this dilation, scale factor of 1/4, then I slide my little tile down here to 1/4, and we're going to answer these questions. Now it's not asking about my endpoints, but it's saying what is the shortest side of the original figure. Now the shortest side is this length right here, which is 1, 2, 3, 4 units, and it is only 1 unit on my shortest side. So if I had to make a comparison between these two lengths and my scale factor, how did they all go together? My original length times 1/4 is equal to my new shortest length. So if I times 1/4 by the shortest side of the original figure, I get the shortest length of my final figure. So true or false, a dilation with a positive scale factor less than 1 gives a final figure that's larger than 1. Well, if I take a scale factor of 1/4, it shrinks it to 1/4 of the size. So is it getting larger? No, that's false. Second question, the original figure and the final figure are not similar. That's also false. Dilations always create a similar figure because they may not be the same side lengths, but they are proportional. All right, let's look at a different problem. So it says, for the figure, do a dilation with a scale factor of 3. So I'm sliding my figure out to 3. The longest side length of my original figure, so the longest side length of this gray is 1, 2, 3 units. The longest side of my final figure is this length, and it goes from 0 to 9, so it's 9 units. Well, how much bigger is that? Well, it's 3 times whatever my scale factor is, so in this case, 3 times as big. So filling out this formula, if I take 3 and I times it by the longest length of my original figure, I get the longest length of my final figure. Okay, next question. A dilation with a positive scale factor, so 3 is positive, let's compare it to that, greater than 1, 3 is greater than 1, creates a final figure that's larger than the original figure. That's right, my blue shape is larger than my gray. Last question, the original figure and the final figure are similar. True. All dilations produce similar shapes. All right, so let's now look at area and dilations. So if I look at this problem and I see that it says a scale factor of 2, well, I notice right off the bat that that length of 4 doubles to a length of 8. So my side lengths are getting twice as big. Now remember, area is not the length of the sides, it's how many squares are on the inside. So 4 times 2, there's 8 squares on the inside here. Okay, and 8 times 1, 2, 3, 4, there's 32 squares on the inside of that rectangle. So the area of the original figure is 8. The area of the final figure is 32. And you can actually just count the boxes if you want to, or we can use like an array. Let's answer this final question. So it says, fill in the statement to make it true. The area of my final figure is how many times the area of my original figure? Now don't just stick a 2 in here, because if I look at my original figure, which is 8 and 32, am I just timesing by 2? Well, no. What am I timesing by? I'm timesing by 4. So actually look to see what it is that you are timesing by. The true or false, the original figure and the final figure are similar. True. Dilations are always similar. The next question says to draw the new image from this triangle. So here's my shape, and it is important when we do dilations, not just to like shrink the shape and say, oh, that looks like it's 2/3 the size, but it's important to always write down the ordered pairs and then translate and then dilate them with a scale factor of 2/3. So that's 12, 12, and this is 9, 9. So what I'm going to do is I'm going to take my calculator and I am going to take each of these points and I'm going to times them by 2/3. So I'm going to start by timesing 12 and 12 both by 2/3. So 12 times 2/3 is 8. So 12 times 2/3 is 8. And 12 times 2/3 is also going to be 8. So that gives me a new point at 8, 8. And I'm going to change colors. Okay, 8, 8 is right here. Now you can always click this tool right here, which is just going to allow me to plug in points, and it will automatically graph it for me. Next point, timesing by 2/3 and timesing by 2/3. Well, we already did it up here. 12 times 2/3 is 8. And 9 times 2/3 is 6. So my new point is at 8, 6. And 2/3 times 9 is, we've already done that, times 2/3. So this is 6, 6. So there is my 2/3 smaller triangle. And it is smaller. Dilations, if it's centered about the origin, are always going to get closer to my origin. Hey, draw my figure with a scale factor of 2. So this time it's going to get bigger, and because it's getting bigger, it's going to slide away from my origin. So I always transform my 2 endpoints. So I have the ordered pairs 5, 6, and 9. Oh, I totally wrote that down wrong. That is not 5, 6. That is 7, 6, and 9, 9. My scale factor is 2, so I'm simply going to times everything by 2. This is 14, 12, and 18, 18. So I'm going to plot those 2 points using my tool. And I'm going to erase that. And I have 14, 12. And 18, 18. So there's my picture, and it is 2 times longer. All right, the last problem is going to ask you about the rules. So it says I have a dilation and it's centered at the origin. So notice it's 1/3, so it's going closer to my origin. It's getting smaller by 1/3. Now, that just means that I'm timesing each of these numbers by 1/3. So 9 times 1/3 is 3, 6 times 1/3 is 2. Now, if I don't have to do that multiplication, I really only have to look at my picture. And you can see that it's at 3, 2. But I want you to know I'm just timesing that x and that y by 1/3. So 3, 2. S is at 4, -2. And t is at -1, -3. Now, which of my rules does it follow? Now, remember what the rules are saying is, really I'm looking at this to see, hey, what's happening to the x and the y? This is saying x was times by 1/3 and y was times by 3, and that's not true. In order to do my transformation, remember I said at the very beginning of this problem that I would just times them both by 1/3. So I'm looking for these options where it says timesing by 1/3. Now I'm between this one and this one. But notice this says yx. That's not the point order. Okay, we're going to choose this one. So that is filling in that rule. That's it for this assignment. If you have any questions, please reach out. I'm happy to help, and have a great day.